Hello, in this video we have this interesting factorial problem. We have n+5 factorial divided by n+1 factorial, and this equals 3024. We are going to solve for the value of n. So what we are going to do is we can express this n+5 factorial as we have n+5 times n+4 times n+3 times n+2 times n+1 factorial. Then we have it divided by, we have n+1 factorial, and this equals 3024. So from here, n+1 factorial will cancel n+1 factorial, and what we are going to be left with, we are going to have n+5 times n+4 times n+3 times n+2, and this equals 3024. The next thing we are going to do is to rearrange this and combine them. So we can easily multiply n+5 by n+2. So we are going to have n+5 times n+2. Then we multiply n+4 times n+3. We have n+4 times n+3, and this equals 3024. So if you expand this bracket, you are going to have n squared plus 2n plus 5n plus 10. And if you expand this, you are simply going to have n squared plus 3n plus 4n plus 12, and this equals 3024. So the next thing we are going to do is to work with what we have inside these different brackets. So we are going to combine them. We have n squared plus 7n plus 10, and here we are going to have n squared plus 7n plus 12, and this equals 3024. Now from here, what we are going to do is we have n squared plus 7n, we have n squared plus 7n. The only difference we have here is this is 10 and this is 12. So we can make it in a way that we have the same number here and here. So we are going to have n squared plus 7n. Instead of this 10, we can have it as 11 minus 1. And here we have n squared plus 7n. And instead of this 12 here, we can have plus 11 plus 1. And this equals 3024. Now from here, we can as well say let x equals n power 2 plus 7n plus 11. And because of that, this becomes x and this becomes x. So we are going to have x minus 1, and this will give us x plus 1, and this equals 3024. So right here, what we are going to do is to expand these two different brackets. If you multiply it out, you are going to have x squared plus x minus 1. This equals 3024. This definitely will cancel this. We have x squared minus 1 equals 3024. And from here, we are going to have x squared equals 3024 plus 1. And this gives us x squared equals 3025. So from here, we can solve for x by taking the square root of both sides. And this gives us x equals plus or minus the square root of 3025 is simply 55. So that means we have two values for x. We have x equals 55 or negative 55. Now at this point, we need to recall let's recall, because x equals, we had a certain variable for x. This is our x, n squared plus 7n plus 11. So we copy down here. We have x equals n squared plus 7n plus 11. And when x equals 55, we are going to have 55 equals n squared plus 7n plus 11. Let's move this over. We are going to have n squared plus 7n equals, we have 55 minus 11. So from here we are going to have n squared plus 7n equals 55 minus 11. We are going to have 44. So we move it over here. This becomes n squared plus 7n minus 44. This equals 0. This is a quadratic equation that we are going to solve using the factorization method. So we need two numbers that if we add, we are going to have 7, and if we multiply, we are going to have negative 44. So the two numbers are, we can make use of 11 and negative 4. 11 plus negative 4, we are going to have 7. And 11 times negative 4, we are going to have this. So that means if we insert these two numbers here, we are going to have n plus 11 and minus 4. This equals 0. So from here we have n plus 11 equals 0, or n minus 4 equals 0. If n plus 11 equals 0, we have n equals negative 11, or if n minus 4 equals 0, we have n equals 4. But there is no way n will equal negative 11, so we are not going to make use of this. This is the only real solution for now. Now the next thing we are going to do is to consider when x equals negative 55. Let's take note of that. So we have when x equals negative 55. Recall we had x equals n squared plus 7n plus 11. Then we insert negative 55 here. So we are going to have negative 55 equals n squared plus 7n plus 11. So from here we are going to have n squared plus 7n equals, we move this over here, we are going to have negative 55 minus 11, and n squared plus 7n equals negative 55 minus 11 will give you negative 66. Then we can bring it down here. We are going to have n squared plus 7n plus 66 equals 0. Now let's check if this will give us any real solution, or we are going to have a complex solution. So we make use of discriminant, which equals b squared minus 4ac. And from here we have a equals 1, b equals 7, and c equals the constant, which is 66. So we have discriminant equals b squared, that is 7 squared minus 4 into 1 into 66. And this will give you discriminant equals 49 minus 4 times 1 times 66. We are going to have 264. So if you subtract 264 from 49, you are going to have discriminant equals negative 215. And this is less than 0, meaning that this will give us a complex solution. So we are not going to consider this value of x. We are not going to consider it. So the only real solution we have at this point is n equals 4. So that is it for the video. Thank you and goodbye.